Good morning, Dr. Ali. My name is San Yushan, number metric AP220238 for Group 17, and our group title is Optimizing Production Strategies for Cafe Kirikanan using Integer Programming to Enhance Profitability Amid Rising Costs. Here's my group member, Chungkagan, AP220527, Erika, AP220409, Fizi, AP220454, and Pangizan, AP220313.
I'll start the presentation with my part, which is introduction. For Cafe Kirikana overview, it is a local cafe chain based in Batu Pahat, Malaysia and founded in 2016. Known for combining traditional and modern recipe at affordable price. Next, for current challenges of cafe, the first challenge is decline in revenue, especially from signature kaya and sambal sauce. Second, increased cost of raw materials, transportation, and labor due to global price hike. For objective, the first is maintain high quality production of kaya and sambal sauce without rising price. Second, enhance customer satisfaction and reputation leading to increased sales and production. Third, optimize inventory management and negotiate with suppliers to reduce costs. For proper solution, we will develop an optimization model using integer programming. The model will help determine the best production strategy, improve resource use, and support better decision making for daily operation. That's all for my part. I will pass to my member.
Before we proceed to the data analysis part, let me talk about methodology. A qualitative approach was employed to address the challenges faced by Cafe Kirikanan in improving its production processes to enhance profitability. Also, an interview between our group member and the founder of Cafe Kirikanan is to gather detailed and relevant information. Besides, there are 6 steps in solving integer programming maximization problem with branch and bound method. So first, solving the original problem using linear programming. Second, find any feasible solution that meets the integer constraint for use as a lower bound. Third, branch on one variable from step 1 that does not have any integer value. Next, create nodes at the top of these new branches by solving the new problems. Next, find the feasibility of any branch solution to the LP problem. And last, examine both branches again and set the upper bound equal to the maximum value of the objective function at all final nodes.
So now let's move to the discussion part, which is we can see here the table 1, data collection of kaya and sambal product from Cafe Kirikanan. So with profit margin of 80 cents for kaya and 1 ringgit for sambal, this company aims to maximize profit while adhering to the constraint of time and minimum production requirement outlined in the table. So after we collect the data from Cafe Kirikanan, we written down the data into a mathematical formulation. As we can see here, the objective function is to maximize the profit, which is z equal to 0.8x plus y, and then subject to constraint. As we can see here, the processing time, assembly time, lower limit, and we use the xy as a integer. Now we need to draw the graph. First, we will draw the line of 3x plus 5y less than or equal to 45 by using the substitution of x equal to 0 and y equal to 0. Next, the same method to draw the line for 2x plus 2y less than or equal to 24. And we also have the line for x more than or equal to 2 and y more than or equal to 3. Then we can get the feasible region, which is in the green colored area. Next, we determine the corner point of this feasible region by solving the system of equation formed by the constraint. The corner points are labeled as A, B, C, and D. Once the corner points are identified, we evaluate the profit function at each of these points to find the optimal solution. So at point A, we find the profit is 4.6 and then point B is 9.4, C is 10.5, and then the last one is 10.2. So the optimal solution is at point C, which is 7.5, and with 4.5 which is giving the maximum profit of Rm 10 ringgit 50 cent. So this conclude all the process to find the optimal solution. So let's move to the next part.
Now we will do the branch and bound method. To find the optimal integer programming solution, first we will take the value of optimal solution as upper boundary. Then we calculate for the lower boundary. We will round down the point C and get the x equal to 7, y equal to 4. Then we sub the value into z, and we will get the value of 9.60. Then we make a square box and put the value of x, y, and z. Then choose the largest non-integer value and split into two sub-problems. We will start with x greater than or equal to 8. We draw the line on the graph and it will intersect with the line 2x plus 2y less than or equal to 24. So we sub the value into the equation and get y less than equal to 4. Then we sub the value of x and y into z and get the answer of 10.40. Set as x less than or equal to 7, it intersects with the line 3x plus 5y less than or equal to 45. So we sub the value into the equation and get the answer of x and z. Since the subproblem A are all integer value, so we will stop doing it. For subproblem B, it still have non-integer value, which is y equal to 4.8. So we will split again into two subproblems. Then we will do the same steps as above, and we will get the answer as shown. They still have non-integer value, so we will split into two subproblems again. Since we choose y greater than or equal to 5, the feasible region only left here, and the x greater than or equal to 7 is out of the region, so there is no feasible region for x greater than or equal to 7. Then we continue the calculations. Now there is no non-integer value, so we will stop at subproblem G and H. Then we will decide the optimal solution by choosing the largest value of z with integer value x and y. Thus, the optimal IP solution is at x equal to 8 and y equal to 4 with profit Rm 10.40. Based on our analysis, it shows that the optimal production strategy for Cafe Kiri Kanan is to produce 8 batches of kaya and 4 batches of sambal to earn a profit of 10 ringgit and 40 cents. This strategy takes advantage of kaya's higher profit margin while still ensuring enough sambal is produced to meet customer demand and fully utilize resources. By focusing on this balanced approach, the cafe can absorb rising costs without increasing prices, helping to maintain customer loyalty and competitive positioning. This demonstrates how strategic production planning is key to sustaining profitability and managing financial challenges.
In conclusion, this study provides a detailed analysis of the operational challenges faced by Cafe Kirikanan, particularly in managing production expenses and sustaining revenue. The finding highlight the importance of strategy decision making in overcoming profitability issue. By analyzing the production constraint and profitability of its key product, which are kaya and sambal, is determined by prioritizing the production of kaya with its higher profit margin and maintaining limited production of sambal and yes and optimize profit for the current resource limitation. Next, to address the operational challenges, Cafe Kiri Kanan can enhance supplier agreement and streamlining inventory system to reduce the production costs. Besides that, they can implement advanced manufacturing technologies to improve efficiency. Furthermore, the company may continuously re-evaluating production plans to adapt the market's demand and resource constraint. Last but not least, By combining the proposed production plans and operation improvements, Cafe Kiri Kanan can enhance profitability, sustain its competitive edge, and ensure long term business sustainability. That's all from us. Thank you.